What if the rules of gravity, the ones we think are totally fixed, weren't quite so solid after all?
Yeah, imagine like guiding things without rockets or maybe sending messages,
Yeah.
not with radio, but with gravity itself.
Exactly. And what's really grabbing me is that this isn't just, sci-fi dreaming anymore.
No, not at all. We've been
S-
digging into some really fascinating stuff, especially from a gravity control podcast and some talks at the Convergence Summit. And the interesting angle is where some of these ideas are coming from.
Right. It's not just staring at gravity equations. Some researchers are finding these connections in, well, electromagnetism, specifically this thing called extended electrodynamics, or ED.
Uh-huh. We all kind of learned about E&M in school, but ED,
Well,
it suggests there's way more going on under the hood.
yeah, like standard electromagnetism, Maxwell's equations, they work incredibly well, obviously.
Obviously. But ED suggests maybe we've simplified things a bit too much, that by looking at more complex interactions, maybe even aspects of the field we usually ignore, we could find new possibilities.
And that's where the potential link to manipulating gravity pops up. It's sort of this unexpected connection.
Exactly.
And for everyone listening who wants to, get the key insights on these big ideas without wading through tons of jargon, this deep dive is basically your shortcut.
Yeah, we're aiming to filter out the most compelling bits from that podcast and the summit talks, specifically on how ED might influence gravity.
We want to break it down, make it understandable, and really focus on what this could mean for the future. That podcast mentioned some real head scratchers, right? Anomalies current physics kind of struggles with.
Oh, definitely. Things like galactic rotation curves, stuff that doesn't quite add up. And alongside that, some genuinely cutting-edge tech ideas, even if they're still mostly theoretical right now.
Okay, so let's dive in. This link, ED and gravity. They seem like totally different things, charges and fields versus mass and warp spacetime. How do they even connect?
Well, the core idea, and it is pretty mind-bending, is that ED's, let's say, deeper look at electromagnetism might give us a way to actually engineer space-time itself. The fabric gravity operates on.
Like the trampoline analogy, mass makes a dip, that's gravity.
Right. ED hints that maybe by manipulating electromagnetic fields in these more complex ED ways, we could create our own ripples. Or even, I don't know, smooth out or reshape parts of that trampoline.
So it's less about fighting gravity directly, more about tweaking the environment where gravity happens.
You got it. The Beyond Conventional Physics podcast, for example, they had Hal Puthoff talking about this, exploring whether specific ED field setups could generate gravity waves.
Real gravity waves, like the ones LEGO detects.
Yeah, the very same. The thinking is ED might offer a whole new way to create them, maybe even control them. And there's also this other angle. Maybe understanding EM better lets us change how materials themselves interact with gravity. Subtly, but maybe significantly.
Okay, this is getting wild. And the Convergence Summit, you said, had some actual tech ideas based on this, like using gravity for communication, UNSPACE.
Yes, UNSPACE. Philip Lentz presented their work, and it's really interesting because they're challenging the idea that dark matter is the only explanation for cosmic weirdness.
Like galaxies spinning too fast, or those pulsar timing glitches, the flyby anomaly, stuff
Yeah,
like that.
exactly those things. Their theory is that dynamic gravity sources, think really dense, fast-spinning things, don't pull evenly in all directions. They create these anisotropic curves in space-time, different depending on direction.
Anisotropic, so lumpy gravity, basically, not smooth.
Kind of, yeah. Standard GR often simplifies for non-rotating stuff. Unspace is the spin, the internal pressures. They make the gravitational effect more complex, more directional.
Internal pressures affecting spacetime, that's a bit hard to picture.
Okay, think of spinning a heavy, slightly squishy ball really fast.
Hmm.
It bulges, right?
Yeah.
It has internal stresses. Unspace is saying those internal dynamics in massive spinning objects actually interact with space-time differently depending on direction. It's related to frame dragging, spinning things drag space-time, but this is more specific.
And they're trying to test this in a lab, not just theory.
Absolutely. With their EGAD experiment, Energetic Gravitational Anomaly Detector, it uses a supersensitive torsion balance.
Right, those things that measure tiny, tiny forces.
Exactly. And they spin these tungsten masses incredibly fast, like you said,
Yeah.
50,000 RPM. The goal is to see if that intense spinning and the internal forces create these measurable directional changes in the local gravitational field. They're looking for tiny radial shifts.
Okay, so making a tiny gravity effect, how does that become communication?
That leads to their RGCS Resilient Gravitational Wave Communication System. If they can understand and create these directional gravity effects, they think they can make a kind of gravitational lens.
A lens. To focus gravity waves, the ones from black holes. How weak are those?
Incredibly weak, yeah. But that's the advantage. They barely interact with matter. So they could pass straight through the Earth, oceans, anything that blocks radio waves or light. So if you
Whoa.
can focus them into a beam and, modulate them somehow, you've got a communication system that's almost impossible to block or jam. Think secure comms for subs or through planet links, totally immune to EMPs or satellite problems.
Communicating through the Earth. Okay, that's definitely paradigm shifting. Let's switch gears, though. Propellantless propulsion, also at the summit, moving without fuel.
Yeah, another potential outcome from these kinds of ED-related ideas. Two groups caught my eye. First, field propulsion technologies, Richard Bandurk's company.
They mention metamaterials and breaking electromagnetic gauges. Sounds complicated. What's the core idea?
Okay, so they're using these custom-engineered metamaterials, nanoscale stuff, and they're focusing on ampere tension forces within them. The breaking the gauges part basically means they're using a more complete version of Maxwell's equations. They're including terms related to electromagnetic potentials and deeper stuff we mentioned that often gets simplified out.
Potentials. Okay. And ampere forces, like between current-carrying wires.
Sort of, yeah. Internal electromagnetic stress is inside their special material. They apply a voltage, get a current flowing, and they claim this amplifies these internal forces in a way that creates a net external push, propulsion.
And no exhaust, just
Yeah.
electricity in, movement out.
That's the claim. And interestingly, the force is opposite to the current direction, which could allow steering.
What are they thinking application-wise?
Big one is space. A space tug, maybe nuclear-powered, zipping satellites from LEO to GEO super fast, no propellant needed. They're working with Northrop Grumman and Sandy on that. Also maybe hypersonic control, reducing drag, stronger materials, even armor. They've got DARPA and NSF funding too, so it's being taken seriously.
Wow, okay. And the other one, Hover Inc., Encore Pot, quantum propulsion.
Right. Hover's angle is, yeah, quantum propulsion. They're talking about a reactionless thruster using energy from the quantum vacuum.
Okay, the quantum vacuum, that always sounds exotic. How do they propose that works?
Their mechanism involves accelerating electrons like crazy. The numbers they quote are astronomical, 820 meters across a tiny gap. The theory, as I understand it, is these hyper-accelerated electrons interact with the virtual particles of the vacuum.
The ones constantly popping in and out.
And this interaction supposedly creates a gradient, like a pressure difference, in the vacuum energy, which results in thrust. They link it to things like the Unruh effect, how accelerating observers perceive the vacuum.
So pushing off empty space, essentially.
In a manner of speaking, yeah, interacting with its fundamental energy fluctuations. They have this Bott-Becker principle, a formula relating force to current squared and electrode gap. And they have built prototypes.
With actual result.
Reportedly, yes. Over 2.5 million newtons of thrust, high-efficiency figures. They have a patent, and they mention independent validation from DARPA and ATS labs.
And the applications there.
Huge potential again. Satellites staying in position basically forever without fuel. Asteroid mining missions that don't need to haul propellant. Continuous acceleration for maybe, reaching other planets much faster.
It's a lot to take in. These are potentially revolutionary technologies. Can we go back to aid for a sec? You said it's deeper than standard E&M. Can you give us that analogy again?
Sure. Think of standard E&M like describing the waves you see on a lake surface, the electric and magnetic fields, the visible stuff. ED says, okay, but what about the currents under the surface, the pressure differences down there? These are analogous to the scalar and vector potentials in ED.
The things that are usually simplified away?
Often, yeah. But ED suggests these underlying potentials are real and can influence the surface waves, the E and B fields, in important ways. Put off mention on that podcast, they might even be detectable directly through quantum effects like phase shifts, even if there's no obvious E or B field around. It hints at this whole other layer to electromagnetism.
Okay, that helps. And how does that connect back to, say, UNSPACE or field propulsion?
Well, maybe UNSPACE's work where internal stress and pressure and spinning masses affect gravity. Maybe that's happening through influencing these underlying electromagnetic potentials, which then interact with spacetime.
Ah, an intermediate step.
Possibly. And field propulsion explicitly talks about using those potentials, working with the less simplified equations. Hover's vacuum interaction. That could be seen as a really extreme case of charges interacting with the quantum vacuum, which itself is tied to these fundamental electromagnetic fields and potentials.
It does tie things together a bit more. So wrapping up, where does this all stand? What's the outlook?
We absolutely have to stress this is early days. Frontier science. The theories are fascinating, the initial results are tantalizing, but um, a lot more rigorous testing and independent verification is needed. Mainstream physics needs solid proof.
Which takes time and effort.
And funding. But experiments are happening. UNSPACE's EGAD, Morningbird Space is doing work with spark gaps trying to generate tiny spacetime effects. Hover has its prototypes. These practical efforts are key.
And if they pan out, even partially,
Then the impact is potentially enormous. Communication, propulsion, maybe even energy down the line. It could change our fundamental understanding of physics. That podcast really hammered the need for more resources and collaboration across fields to push this forward.
So no anti-gravity cars next week, probably.
Probably not. But the theoretical groundwork, combined with these first experimental steps, it offers this really compelling glimpse of a future where we might have a much different relationship with gravity and electromagnetism.
Okay, so hopefully everyone listening now has a better handle on these ideas linking advanced EM and maybe, just maybe, gravity control.
Yeah, the key takeaways. Extended electrodynamics explores this deeper electromagnetic reality with these potentials, and that might open doors to manipulating spacetime for things like communication and propulsion. Research is ongoing. Lots of challenges remain.
Which leaves us with that final thought. If we really are starting to figure out how to, let's say, engineer spacetime, what other fundamental limits that we take for granted might actually be more flexible than we think?
Definitely something to ponder. And if you want more detail, absolutely check out the podcast and the summit resources we drew from. It's a fascinating journey.
A journey indeed. And with that sense of possibility, we'll wrap up this deep dive. Join us next time as we explore